Hi, everyone. I'm Sophie. I teach at a program called CUNY START at the Borough of Manhattan Community College. CUNY START is a program for students who are just transitioning into college. A lot of our students are just coming out of adult education and adult literacy programs. And they have been determined by the college to have remedial or developmental math needs. I love my program. It's kind of unique because we teach with a very student-centered, question-based teaching style. We do a lot of asking students to ask their own questions, and also as teachers, we give them very few answers and instead ask them to kind of solve problems on their own and come up with their own answers and explanations. So that's been really rewarding for me. I'm going to pass it to Eric.
Yeah, so I work with the CUNY Adult Literacy Program. So we're both at the City University of New York, but in two different programs that are related, but separate for sure. In an ideal world, our students would go on to CUNY START if they're interested in college. But I work with 14 campuses. I work with CUNY Central, so I'm not working with any particular campus, but we have campus programs that in basic education, literacy, high school equivalency, ESL. Most of my work is supporting math teaching, so I write curriculum and do workshops with teachers around teaching math. And Sophie and I met a few years ago in some PD for CUNY START, and got connected in our math circle, teacher circle together that way. And we'll say more about that later. So should we jump in?
Yeah. Yeah, so just to say a little bit more about the teacher circle that Eric and I work together in. It's called the Community of Adult Math Instructors, or CAMI. And it's a group of teachers who come together a couple times a month and just kind of do math problems together or math explorations. Something that I really love about CAMI is that people come in, it's mostly adult literacy or teachers of kind of early college math. And it's a really diverse group of teachers. So we have some teachers coming in with, they've studied math at the graduate level. We have other teachers coming in who have almost no background in math at all. And the result is that it's a really positive and safe space for people at all different levels to do math that, is kind of at their own level or is a challenge to them. It's a chance for all of us to kind of put ourselves in our students' shoes, kind of feeling vulnerable and tackling math that might be a challenge for us. We also, we do practice this problem posing and problem solving approach to math that we'll be talking about in today's workshop. So we do these open-ended explorations that start with the problem posing process that we're going to do today. So if some of the work we're doing today is something that interests you, we would really welcome you to come try out one of our CAMI meetings, and we'll give you the contact information at the end of the session.
So we'd like you to consider this quote from Diana Lambden. It comes from a book called Teaching Mathematics Through Problem Solving. So in the quote, well, here's the quote. No matter how kindly, clearly, patiently, or slowly teachers explain, they cannot make students understand. Understanding takes place in the students' minds as they connect new information with previously developed ideas. So I'd like to ask you to consider this quote. Can you tell us in the chat? Do you agree? Do you disagree? can you give us an example or an explanation of, how you understand this quote, whether you agree or you disagree? Let's take a moment and get some stuff in the chat about our response to this quote.
So Eric and Sophie, you both have the chat so that you can see it?
Yeah.
Okay.
If you agree, tell us a little bit about what resonates with you. Bella says scaffolding. Bella, am I pronouncing your name correctly?
Yes.
Thank
Yes,
you.
you are.
Thank you. Could you tell us, what do you mean when you say scaffolding? What do you mean?
Basically, having some basic knowledge or building on it one step at a time, making sure the foundation is very strong. If you start kind of at the top and go down, the students will topple. They will not know what they're doing. So make sure that the base is strong, concepts are strong. They've thought those through by multiple ways of them learning, different ways of teaching them, and then build on it. And most of the time, if the base is strong, they can figure out most of it on their own, a lot of it, not most of it, a lot of it on their own. So they can put 2 and 2 and it becomes 4, and it's not 2 plus 2 is, I don't know what that means. So I think that's what I meant.
Thank you, thank you. And Kelly and Aggie, please correct me if I'm pronouncing your names incorrectly. You both wrote about negative and positive numbers. Kelly, would you like to say something? Could you explain your example?
Hi, I actually worked in K-12 for a really long time, and now I work overseeing adult literacy programs. And I can tell you that from teaching in a K-12 classroom, whether I was teaching high school or 4th and 5th grade, the number line was so challenging. And no matter how many times I tried to explain it, or how slow, or different physical examples in person, no matter what I did, there was always some students that just couldn't connect with it. And I recently observed an adult ed classroom, and they were going over negative and positive integers and the relationships on the number line. And it threw me right back to the classroom. And that quote is perfect, because it didn't matter how slowly, how clearly, how patiently. It might resonate with one, but there would be one that thought they understood it, but now they're confused because you used a different example. So I think it's a really good quote specifically for that lesson, in my experience anyway.
Thank you, thank you. And Aggie, did you want to add anything to that?
Yeah, so I discovered that many of my students are visual learners, and the number line, as to Kelly's point, was confusing. It's because they don't see left and right. They see patterns. So they've been doing math with patterns for a very long time, but they never realized it. So I made more headway with them building patterns than I did with the number line, because that's what they have been using. These are like 23-year-olds or 19-year-olds or 26-year-olds coming into my classroom, and they're failing these really basic math tests. And I couldn't figure out why they were failing them. But then when I got into their heads a little bit, I started to see that they are a pattern-based learner. And if you go with what they already know, then you're fine.
Thank you, Aggie. So there's other comments in the chat, and I'm not going to have time to follow up on each of those, but I encourage you to keep the conversation going there, and we will have times as we go to unmute and keep talking through this together. I want to add one piece to this quote. So this is just to finish that sentence. I'll read it again. No matter how kindly, clearly, patiently, or slowly teachers explain, they cannot make students understand. Understanding takes place in the student's mind as they connect new information with previously developed ideas, and teaching through problem solving is a powerful way to promote this kind of thinking. I'm wondering about what the implications for our teaching. So, I mean, if it's true that we can't make students understand, there's, you know, learning, understanding is something that happens within a person, within a student, within a learner. What are the implications for teaching? And you could put it in the chat, you could unmute. Lorraine, you wrote critical thinking is key. Could you tell us what you mean when you say critical thinking?
Oh, hi. What I have found with my ESL students is getting them to think on a critical level, to answer those questions in a deeper level is what I have to help them get to. So without critical thinking in any forum, mathematics, social studies, histories, ESL, all of the things that we teach needs to be carefully scaffolded as we've talked about. And we have to have really clearly defined strategies to assist our students. It's complicated.
It's complicated.
Yeah.
You know, it's interesting. I'm going back in the chat and I'm noticing what Terry wrote. Terry wrote, I agree with the statement. Everyone has a different way of teaching and learning. You can hear it from two different teachers and one you get it, but not from the other teacher. Terry, could you talk a little bit about that experience? If you wouldn't mind unmuting.
Terry, I think you might still be muted.
There we go. I got it now. Sorry about that. We've had it quite a few times in our AVE classes. We can have two teachers teaching the same thing, and a student will hear it from one teacher, and still you look at them like they've got 15 eyes, and then they hear it from another teacher or even from another student showing them an example. And they're like, well, why didn't so-and-so say this? You know, sometimes it's just wording or the way you phrase it or the tone in which you use. It happens.
Thank you, Terry. I also hear in your explanation this thing about, you know, it's the learning is happening in the person, in the student. And it's a little bit unpredictable maybe about when something will click and something when it won't. So just to say a little bit about, I mean, our understanding, I guess, because there's many different perspectives on problem solving and teaching with problem solving and problem posing. But our understanding of that, at least as the way we use it within our math teachers circle, we're focused on our own learning as teachers. We're also considering teaching and in our own teaching, but our primary experience and the thing we're concerned about when we're working in our math teacher circle is our own learning. And what we're thinking about is how to develop understanding without a teacher's explanation. What can we learn without a teacher's explanation, and how maybe can we teach without explaining? My guess is that you may be a bit skeptical of this idea. I would be surprised if you're not. I mean, maybe not everybody, but it's not generally how we think about teaching and learning. I think we think about, you know, the power of teachers to explain as being the most important thing that they do. I think that tends to be the way we think about teaching, but we're trying to practice a different way of learning. And learning without explaining quite. Maybe explaining in terms of how we're learning, but not in order to make someone else understand. Anyway, so instead of talking more about what that approach would look like, we would like to share one of our activities so you can experience it a little bit, and Sophie's going to lead us through that. So when I guess I'll just jump in, right, Sophie?
Yeah, so I just kind of want to add to what Eric was saying, that something that has been kind of a shift in my teaching has been thinking about what can I show to students to get them kind of thinking or developing ideas without me really having to say much at all, and maybe just only asking questions. And so we'll kind of just walk through a little example of that. We have this image here, and I'm just going to ask you a question. The first question I'm going to ask you is just, what do you notice as you're looking at this? So I'm going to ask everyone to just take, you might want to like grab something to write on, like a piece of paper or a Word document, whatever. Just take a moment and just kind of jot down whatever you notice as you're looking at this, whatever comes to mind. We'll take about 3 or 4 minutes to do that. Okay, so I'm seeing a lot of interesting ideas in the chat. I'll ask you to kind of keep jotting down your ideas, things you notice. But we're also going to go into breakout rooms and give you guys a chance to just chat with each other and share your observations together. And while you're doing that, Eric is going to put a link in the chat to a Jamboard. Does anyone here, I'm assuming maybe just given the pandemic, some of us have experience with Jamboard. Can I maybe just see a show of hands, like who's used Jamboard before? Okay, seeing some hand raised, thumbs up. Okay, so what we'll do is just ask in each breakout group if one person with the Jamboard could share their screen, just so that maybe some people who can't access the Jamboard or who are having difficulty with it will still be able to see and follow along. Does that sound like a good plan?
Yeah, Ying Hong, did you have a question? You had your hand up?
Oh, no, I'm just saying, I know how to use Jamboard.
Okay, okay.
Yeah, I look for a show
Sorry.
of
All right.
hands, yeah.
All right,
All right.
so it's good if everybody gets that open before we do the breakout room, just so, because you have any general questions, so.
Yeah, and I think as long as at
Sure.
least one person in
Yeah.
each group can open it and share. So you'll just see in the Jamboard, there's a few different slides, all with that same image, just so you guys have something to kind of look at and chat about. Okay, and we'll go to breakout rooms for just about 5 minutes
Okay,
to share.
I'm gonna create the breakout rooms now.
All right.
And then we'll send a message via the broadcast when there's about a minute left. Okay, all right, so I'm creating the rooms now. And then Sophie and Eric, you're just not gonna join it, that way you can kind of jump around. All right, so most people are accepting their invitations. Anybody not seeing the thing come up on their screen? All right, room 8 is almost full. All right, so for the folks that haven't gone into a breakout room yet, have you seen the invite?
Should say, you're invited to join a breakout room.
Yeah. All right, breakout room 8 is full.
If anyone's not able to go, people could stay in this room. So you could unmute and talk here if you want to, just share what you've noticed.
All right, Nawasha, I'm gonna assign you to a room. I'm gonna assign you to room 6. All right, 124. So you're thinking like 1:30-ish?
Yeah, maybe a little bit earlier.
Okay,
Yeah, maybe 128, 129.
okay. I love it when it's that discreet. 128 and a half.
My students get very annoyed at me because I'll tell them, you have to be back from your break at 11:36.
That's yeah. We're in one of our discussions yesterday, we were talking about Jamboards. And I was saying how I've taken to, when my students are in breakout rooms and using Jamboards, I'll go into the Jamboard and I'll use a sticky and I'll communicate with them via the sticky rather than joining the breakout room. Because I always feel like that's just so jarring that you're having a conversation and all of a sudden somebody's like, hey, how you doing? And you're like, oh. so
Hey, Eric, I'm sorry to interrupt. Nawasha is requesting you move her to group 8
okay.
because she is on a second device, I believe.
Okay. All right. So
And anyone who's still in this room, if you would like to start sharing what you notice.
Yeah, absolutely. I'm interested in hearing what people are thinking about as they look at this.
some other folks I think just joined, so I'm assigning them to rooms now. All right, so I'll broadcast the message to everybody saying 2 more minutes. This is somebody else's Zoom account, so I don't know whether they have it as the when I close it, they get a minute, or when I close it, it's closed. So Diane's chiming in saying each image counts up to another number. So it's a Fibonacci sequence. If it's 1, 2, 3, 5. All right, I'll give them 1 more minute. All right, I'm going to close the rooms now. They have a minute, so probably most of them will come back early. All right, about another 20 seconds and everybody's going to be back. All right, everybody's back.
Great. Okay, welcome back to the main room. So I'm seeing a lot of observations in the chat. I want to just invite anyone who hasn't already started to share observations in the chat. Feel free to start contributing now. But maybe let's take a couple moments to highlight a couple of these things. So I saw in the chat a number of people were noticing just this sort of counting as we go from one shape to the next. I see that it looks like Diane was saying each image counts up to another number. Yvette was telling us that this is a nice visual for visual learners, that we can kind of see the numbers 1 through, let's see, what is it? 1 through 20, 1 through 21, as we move through the shapes. I'm also seeing, let's see, I saw that, who was it who mentioned, sorry, there's so much in the chat.
So Anna mentioned seeing factors of every number.
Yeah, a couple of people mentioned factors. Anna, do you want to say a little more? Where are you seeing factors? If you're comfortable turning on your mic.
Oh, sorry, I was trying to figure out where the mic was. Okay, so the most important thing what I noticed is all the circles are prime numbers.
Interesting.
All the circles are prime numbers. If you can take a look at 1. Okay, number 3, maybe it's, but it's a triangle, but it's the kind of circle as well, because you cannot make a circle out of 3. Anyway, 5 looks like closer to circle. Then 7, well, you can see definite circle. And then you can see 11 circle, 13 circle, and then 13, 14, 15, 16, 17, and 19. They're all prime numbers.
Okay, interesting.
And then you can see like everywhere factors, whenever like every single factor. For example, we can take a look at number 15. You can see 3 and 5. And there is no other factors in number 15 other than 1, 15, and then 3 and 5. And you can clearly see that there's 3 groups of 5. Number 10, 5 groups of 2. And there is no other factors. 9, 3 groups of 3. You can see it right away. Like the last one is, what is it? It's 18, right? 18, so it's 6 times 3.
Are you looking at this one here?
The last one. The last one is 18. The last one is 18. So you can see 6 groups of 3, right? So 6 and 3 are factors of 18. What other factors? 2 and 9. I don't see 2 and 9 though. So not all of them are mentioned, but many of the factors are mentioned. Number 16, you can see that it's 4 by 4.
The last one is 21.
Yeah, the last one is 21, and 9 is not a prime number. So,
the last one is 21. So it's 7 groups of 3, right?
Yeah, that's good.
Interesting.
7 groups of 3, and there is no other. There is no other factors. So that's right.
Mm-hmm.
Interesting. Denise, when you were talking about 9, where were you looking?
This one, the second row, second one, 3 groups of 3 is 9, and those are the only, the only factor, like Anna mentioned, are 1, 9, and 3. So
interesting. I also noticed that some people were mentioning I think it was Laura who it looks like maybe got logged out, but I'm interested if other people notice something similar, that there's some kind of pattern in where we're seeing the different shapes. Like what are the other shapes aside from circles that are showing up?
The triangles in 3, 6, 9, 12.
Okay, so we've got some triangles showing up.
The squares are the perfect squares, like 4 and 16. 4 and 16, and then 9. What's going on with 9? 9 should be 3 by 3, like perfect squares. We can clearly see perfect squares. It's either perfect triangle or perfect square. So they're all perfect square numbers, like 1, 1, 4, 9, and 16.
So as I'm hearing all these different,
you can see pentagonously, number 5, 10, 15, and 20.
as I'm hearing your different observations, I'm seeing a lot of overlap. The next question I want to ask everyone is, what are you wondering? What questions are starting to come to mind as you're looking through this? So again, I'm going to ask us to pause. And this time I want to kind of ask everyone to hold back from putting your thoughts in the chat. Maybe just chat them or jot them down on your own piece of paper. What questions are you wondering about as you're looking at this? Let's just take another 3 or 4 minutes to jot down some questions.
When I introduce this activity to students, sometimes the notice, what do you notice and what do you wonder? I will sometimes give a few examples of what I mean. So like, what do you wonder? What's something you're curious about? Something you want to know more about? A mathematical question you could ask after looking at this image. Something you're curious about. And then what do you notice? Usually what seems important, what's interesting, what do you see, what stands out?
I'm interested in hearing some questions that are coming to mind. I see a couple starting to show up in the chat, but also if you would like to turn on your microphone and share a question, we'd love to hear them. I see in the chat, Jaspreet is saying, why do you use different shapes to teach certain things? Eric's wondering if the shapes will start to approach each other. I'm interested, Eric, can you just say a little more about that?
Yeah, so that as the pentagon shape gets bigger and bigger and bigger, will it start to resemble a circle more? You know, like I've seen proofs of like how we figure out the square of the area of a circle, right? And it's all these triangles, and the difference between the gap gets smaller and smaller the larger the circle gets. And so I'm wondering, the bigger and bigger a pentagon gets, would it start to closely resemble a circle?
Oh, that's really cool. I just wondering, which numbers are you seeing that are already starting to look like pentagons, or that are pentagons?
Well, the 5 and the 10, right? But then the 15 is already starting to, I could kind of see it starting to get a little, and then by the 20, I could, you know, to draw it, it would be just as easy to draw a circle as to draw a pentagon around it.
Okay, interesting. Lorraine, your question is interesting. How many more can we add to this? Do you want to say a little more about that?
Hi, I'm not a math teacher. Let me start by that. So for me, looking at this, I would be curious, like, can we add, how do we do that? Like, I don't even, I'm just looking at it visually. Can I put another row on this? And if so, how would I be creating that visually?
That's a great question.
Yeah, strictly a visual learner.
Cool, yeah. Were other people also wondering about kind of how to continue the sequence? Did anyone have similar questions? Jane, I'm interested in your question. Can you say a little more about that?
Sorry, I had the Jamboard covering. I just thought, like, what if I just picked this, you have to look at it. What if I picked a number and said 77? How should that be drawn? You know, without having to draw and draw and draw.
That's a great question, yeah. Did anyone else also kind of start to think about how could I come up with a next number or a bigger number in this sequence? Interesting.
So if you want to build a 77, then we will see from the second row, the fourth one is 11, right? So there will be 7, 11, that figure, that circle. So I'm curious, what will be the biggest number that in this question, how far we are going to reach? That is, yeah.
Yeah, that's a cool question.
So obviously from the figure that we can see from here, we can build more, we can build a figure with a bigger number out of those given figures, right? So it depends on how big a number it is.
I'm interested, that's sort of an assumption everyone seems to be making, that we can build more. Is there anyone who kind of doubts whether we could definitely keep building? Is that something we all kind of agree on?
I think we can keep building. I think it's just a matter of keeping track of what we're building. I think that's the hard part. I mean, how many circles can you make and remember, like, you know, how many little circles are inside that bigger circle?
Interesting. Josephine.
To me, this is to just you know, introduce it to the students to make sure that they understand factoring, and then continuation of that doesn't really make much sense. If they understand up to 21, they can continue in their head to, you know, to build patterns as long as they understand it. But it's difficult to actually teach the students to think this way, to the factoring way. They don't usually try to think. They just, okay, you know, move on. I don't understand this. And then we have to come back to return them to, no, you got to understand this. If you don't understand this, then you might not be able to understand something that has to do with this, because factoring it's the major topic. It's like, you need to know it.
I'm interested because a lot of people have kind of focused on the factoring benefits. But I'm seeing other questions as well. One thing that Josephine mentioned in the chat, the idea that the smaller numbers kind of get used repeatedly. Can you give an example of that? Just like, what are you seeing when you look in the image that you're seeing the smaller numbers repeat themselves?
So if we look at the second image in the second row for 9, it's 3 groups of 3. So that first triangle of 3 is used 3 times to represent 9. We go farther down to 15. That group of 3 is used 5 times to get 15, whereas you could have done the pentagon of 5 circles 3 times to get 15. So it really does go back to the idea of factoring the numbers, factoring the bigger numbers into the smaller shapes.
Yeah, absolutely. That's interesting. So I guess that kind of makes me wonder, as we're talking about finding further numbers in the sequence, do people have ideas of like how we would actually go about creating more numbers?
It would be if you have 2 facts, so all numbers are the products of 2 primes, right? So that's math, law, whatever. There's a conjecture for that. I'm sure it was proven at some point. And then, so if you want to do something like, say, 9 times 9, well, 9 is a triangle with 3 smaller triangles. So you just have 9 of those bigger triangles forming yet a larger triangle. So, so I guess, and this is the part which I'm saying, like, you can always build, but it's just keeping track of it in your head. I mean, this has to be some student with some incredible visualization skills to be able to do this, to keep track of it. I would probably lose track at around like 7 times 9. Like I might lose track at that point. Like I can't put it in my head anymore. But maybe there are students out there who can put it all in their heads and see it.
Yeah, that's interesting. And I think it was...
And it will be duplicated, I think. For example, if you want to make 15, and you can have like 3 of 5 circles, or 5 of 3 circles. And yeah, which one you're looking for. So it depends on what is the question.
Yeah, that's an interesting question. So someone had asked about how would we make 77? Is there only one way to make 77 with this pattern? Or are there multiple ways that we could make that same image? I'm also seeing Denise's question, what would 22 look like? Aggie, that kind of made me wonder, do I need to know what 21 looks like in order to make 22, or could I jump ahead? Someone else had also asked that. Is there a way to predict really large numbers without having to go through? So I think these are all really great questions. In a typical session, we might kind of continue. What we've just done here is that first step of posing questions. Now we have this really long list of questions. They didn't all make it onto Eric's list in the Google Doc, but we have a whole bunch of questions in the chat. For the sake of time, we won't be able to kind of go deeper and start answering the questions. But I do want to talk a little bit about just where we would typically go from here. Eric, did you want to add anything before we go to that next slide?
I was wondering, I know we don't have a lot of time, but I was wondering if you could look at this animation just real quick.
Yeah, it's really fun. Yeah,
okay.
Go ahead.
So this visualization of numbers was made by a programmer, and I think someone followed up and did an animation for it. So we'll put a link to this in the chat, but this is the first number, and I'm gonna let it play. 4, 5, and you just see what you notice, what questions you have. Feel free to add in the chat what you're noticing. So I just hit pause. I think that's where we last left off. Is that true? 21, 3,
Yes.
6, 9, 12, 15, 18, 21. 21. Okay, so here's this is new territory here. 22 is one we talked about. Makes me start to think about Eric's question about whether they get more and more circular. But I think we'll probably have to leave this. We put a link in the chat. I could stare at this all day. It goes all the way up to like 1,000 or something, I think. So enjoy it.
I think the first time Eric showed this to me, he then accidentally left it running for several days and came back to find that it had gotten quite large.
It does end eventually.
Yeah, I also kind of liked bringing in the color element. Again, we could go through a whole another round of posing questions now that we have this animated version of the image. And, you know, it does get at that question, maybe the animation ends, but could we keep going? I think those are great questions also. So thank you everybody just for sharing your questions and getting us started.
I think we're gonna do a little reflection. Is that right, Sophie?
Yeah. So let's go back maybe to the slideshow. And we wanted to just take a little bit of time to think about how an activity like this, a sort of typical problem solving approach activity could apply to our own teaching. So let's just take a moment, maybe on a piece of paper, you can write down this question or your thoughts about this question.
I think you could put it straight in the chat too, if you like. What was this activity like for you? Yvette, would you mind unmuting and telling us about your experience? You said it was engaging and fun. What was engaging about it?
Engaging where everyone was able to collaborate and share their thoughts individually. Fun because it provided the black and white, but then it became super cool, like Laura said, when the colors came on. So I thought that was a fun activity.
Thank you, Yvette.
You're
Appreciate
welcome.
And I'm wondering, is there anything in here in your experience of this activity that you would like to incorporate into your teaching? How would you apply your,
Oh, I incorporated this 5 minutes ago with a student of mine. I just emailed it to him.
Not even
This kid
offer.
is so smart. Like I can't even describe to you how smart this kid is. For the life of him, he can't remember how to multiply. He does that. He's got procedural memory issues. But this kid is so smart. I'm going like, he might be one of these highly visual. He's like, let me see how far he can get. I was like, can you use this pattern? Show me what 91 will look like. Let's see if I can come up with it.
Very cool. Thank you, Aggie. Lorraine, could you share what you're referring to? You're saying connecting numbers to music, art, and science?
Yeah, I think someone mentioned it a little earlier about just how it looks so amazing, but more like I was thinking of my needlepoint days. I don't needlepoint anymore, but I used to. And like all of how everything, we do really see the world with numbers, but it's not explained to us like that. And if we can get our students to see numbers as being these really friendly, wonderful parts of our world, then we may not have that fear factor that math brings to people. So it is connected to everything. I'm even thinking of ways to use this to teach my ESL students. Recognition of the alphabet, recognition of grammar. It's all connected, at least in my mind. Numbers are connected to everything, or patterns are connected to everything.
Thank you, Lorraine. That's really lovely.
One of the things that it seems to me is that, you know, in virtual space, people have been bemoaning, like in math and science, where in the past you could use manipulatives to use the kinesthetic or the proprioceptic part of learning, that these images are as close to tactile as you're going to get without VR, right? So that you can't touch them, but you can really move them around, you know, you can adapt them and modify them. And so in some ways that may bring, you know, the manipulative to the virtual space, even if you don't have some expensive AutoCAD program.
I work as IT programmer before, so for this question, I think it's well programmed, and how to show the pattern, how to show the number with different pattern is well programmed. So if it's a good topic. If I introduce my students with this topic, I'm definitely going to show them how computer programming gonna do with this topic.
Thank you. Thank you. So I'm sorry, I'm gonna have to move us along because we only have a few minutes left together. So I just want to say a few words about our approach to learning together. I mean, some of us use this in our teaching, but you know, but we're many different kinds of teachers. Some of us teach math, some of us don't. It sort of depends on the context, whether we're using someone else's curriculum, whether we decide on what we teach ourselves. But in our math teacher circle, when we're meeting together and learning from each other, this is the approach we use. So we use open-ended problems. So oftentimes there isn't just one question. Sometimes there isn't a question at all, like in this one. They're non-routine, meaning like there's no specific way to solve it, right? I mean, there may not even be a problem. Sometimes there is more of a problem. In this case, it's not really a problem, it's just a visual. But there's not like a memorized solution or memorized strategy to solving these things. Sometimes you can bring your background information or knowledge, but it's not like there's just one way to solve it. And so we're looking for many different ways of solving, or many different ways of thinking about the math we're looking at. So even for those who, you know, who might have more experience with math, they're seeing other ways of thinking about it. So they're seeking to understand other experiences, other visualizations, different strategies. We work in small groups and we present back to each other. And so at this point in the meeting, we would break up into smaller groups, do some work on visualizing, I don't know, maybe answering any of those questions we came up with, or visualizing some of those larger numbers, and then come back and present to each other about what we learned, and presenting these different strategies. And so we're focusing on the strategies, not the answers, and you know, focusing on our own learning. Just in our last few minutes here, this is back to Sophie.
Yeah, so, you know, what we just did was this sort of first stage of generating questions. If we'd had more time, we might have gotten to do a little more and start answering those questions. But we just wanted to share a few different approaches to structuring a math activity after generating the questions. So as Eric was saying, in a CAMI circle, or in a sort of more experienced group of students who are more comfortable with this approach, we might just kind of leave you guys with these questions and say, go ahead and start answering, you know, pick a question and start answering it in your groups. In a group of students that needed a little bit more structure, we might have a few questions in advance that we were planning to ask students. you know, sometimes those questions come up in that wondering session, and I might say something like, oh, you know, I was really interested in Diane's question there. So maybe that's one we can all agree to focus on together. Or we might have a few kind of push questions. So as students are in groups, we might go around and have questions to get them thinking. I might ask a group of students, can you guys try and draw 30? Like, let's see what 30 would look like. Or, you know, do you notice any patterns in all the even numbers? Any, you know, maybe we heard from Anna that the circle numbers are prime. I might ask other students to think about circle numbers. And then a common question we often want to ask is like, what's the general rule here? I think asking students to make general rules and patterns about how things are drawn is a really nice bridge into algebraic thinking. And so we might ask questions like that as well. And then at the end, after the group work, we'll have share backs and start to draw more general conclusions. So you can see how without using the word factoring at all, we've just given students something to look at, and they can kind of start to draw their own conclusions about factoring.
So Eric, I think you said something really important, which was that sometimes, I think Sophie, you suggested this as well, sometimes there's not even a question, right? And I think that's really important. It is sometimes productive before you pick up a book to read or watch a movie or, sit down with some data to have a question in mind. But sometimes we don't know what we're looking at. And so we don't really have a question yet, right? And so sometimes our questions come after we've interacted with it for a while, right? So like, I always give this example in a literacy class or a language arts class. Say I said, all right, so what questions do you have about, Saturn's moons? You might be like, how many are there? Like, it wouldn't be a very interesting question, right? But and if we read a little bit about Saturn's moons and talked about them, and then I asked you, what questions do you have about Saturn's moons? Then you might be like, oh, how many do have potential for water? And how is water connected to life, right? So questioning is one way to in, but it's not the only way in, right? And so I think the example that you both provided here is that I don't necessarily have a question, but I start to poke around and see what's there. And then maybe a question develops from that, but I don't necessarily have a question going in. I just kind of have an open mind, just trying to look around and see what's there. Don't really.
Thank you, Eric.
But
no, go ahead. Sorry.
So I was like, I don't know where that leads, but so I know that some people have to teach, and so they're running from one section to the next. So I just want to thank Eric and Sophie for a very, very informative session.